In collaboration with teams from the Pueblo Chemical Agent Destruction Pilot Plant, the Program Executive Office, Assembled Chemical Weapons Alternatives, the United States Department of Defense, Amentum, CRG Automation, Bechtel, and others, we came together as one team with one mission.
Welcome to the Improved Cavity Access Machine, also known as ICAM. The purpose of the ICAM is to receive 4.2-inch mortars, which have had their energetics removed and automatically process each munition by accessing the agent cavity, draining and transferring the agent to the existing agent collection system for further processing by the facility's agent neutralization system. Then preparing and packaging the drained munition bodies for thermo treatment and final destruction. Based upon a decision by PEO Aqua, the improved cavity access machines were designed to replace the existing cavity access machines to reduce worker risk, lower maintenance requirements, and increase washout efficiency.
The 4.2-inch mortar entered into service in 1943, and a non-chemical version of the weapon was used in the Second World War and subsequent conflicts since that time. Although chemical rounds were never used by the United States, they were manufactured and stockpiled for retaliatory use. These AG munitions are now obsolete and scheduled for destruction under both an international arms control agreement and congressional mandate. Mustard agent, purified Levenstein sulfur mustard, or distilled mustard, has a 5% sulfur impurity, less odor, and greater blistering power than the original undistilled agent used in World War I. Mustard agent is also known as H, HD, or HT. The weapons being destroyed in this new process have been stored at the U.S. Army Pueblo Chemical Depot for decades. Safety is always at the forefront of any project we tackle.
My name is Bobby Phillips. I'm a mechanical engineer working with Aqua in the Anniston field office. One of the main decision factors of this project was to improve the safety posture of the current design. With the new ICAMs, we reduce the complexity, increase the reliability of the system, so it reduces our maintenance requirements, and that translates to fewer toxic area entries where we have to go in and work on the equipment.
Over time, the stored mustard agent tends to degrade and form solids, also known as heels, within the mortar's agent cavity. Heel deposits formed on the horizontal collection surfaces after 65 years of laying on their side within their original storage containers, as seen on this diagram. Once the mortars were reconfigured and reoriented to the vertical position to support demilitarization operations, the semi-solid heel material migrated to the base of the agent cavity, while the solid heel continued to adhere to the sidewall and baffles. Both of these heel conditions are expected to be seen within the HD mortars. Historical mustard mortar processing have indicated heel material up to 30% of the agent total volume. This diagram shows examples of various heel locations by percentage. The mortar under each percentage category is the immediate state of heel when reorienting from the horizontal to vertical position. The mortar on the right is an example of what the heel might look like after additional time in the vertical position. There are currently 2 processing lines located in the munitions washout system room, with each line planned to accommodate 5 improved cavity access machines and 1 FANUC robot for material handling. The improved cavity access machines were designed to be installed on the existing mounting pads, maintain the same utility connections, and operate on the existing facility control system in Pueblo. Starting in the material receiving room, or the MRR, the PCAP team will receive a pallet of 24 4.2-inch mortars. From there, the mortars are hand-loaded onto the existing input conveyor and conveyed base end first, one at a time, and driven to the end of the input conveyor, which is a slightly sloped section. The next mortar is fed and is held at the bump stops on the MWS conveyor. When the robot removes a mortar from the line, the bump stops are lowered for the next mortar to progress, and the operator in the MRR loads the next mortar. The material handling robot will remove an incoming mortar from the input conveyor and place it into one of the 5 CAM units, whichever is available and in operation. Once placed, the ICAM will move the burster well extraction station into position over the mortar. After years of storage, pressure can develop inside the mortar from the degraded agent. This pressurization may cause frothing events when accessing the cavity, which must be contained. ICAM will accomplish agent containment through a vacuum chamber system, coupled with mechanical seals and an enclosure. After removal of the burster well, the ICAM will wash off any residual agent from the exterior of the burster well before inserting it into the burster well punch station, where the burster well is punched in 2 locations, resulting in 4 vent holes. Once completed, the agent removal and wash station is moved into place over the mortar. The ICAM will access the mortar's agent cavity with a dual-function wash and vacuum wand.
The wash system effectively cleans and removes agent heel material from all surfaces, while the vacuum system effectively removes liquid agent, the broken up heel, and wash water to less than 0.05 pounds.
Once a wash vacuum cycle is completed, the burster well extractor station is moved back over the mortar, and the burster well is then reinserted into the mortar cavity for further processing downstream.
The mechanism here punches holes in the burster well. As the burster well is replaced into the mortar during the munition treatment process where the mortar is heated up, the holes in the burster well allow gases to vent out. So on the wash wand, there are 10 different nozzles on the bottom that will wash the inside of the mortar as it moves up and down during the washing process. In the center of this wand is a vacuum collection tube that will bring the wastewater and the agent out.
At the completion of an ICAM wash drain cycle, the material handling robot will remove the wash mortar and weigh it on the output conveyor weigh station. If the mortar weight is deemed acceptable, the mortar will be conveyed onward to the munitions treatment unit room for further processing. If the mortar weight is not acceptable, the material handling robot will return the mortar to an open ICAM for an additional wash drain cycle. At any point during the ICAM wash drain cycle, if the control room operator determines a defect or failure, a reject sequence can be initiated, which requires the robot to remove and place the mortar on the reject table, where a DPE entry will be made to inspect the mortar and, if necessary, overpack and remove the rejected mortar.
We're getting ready to go to a multi-line demo. ICAM 1, 2, 3, 4. We'll put those in auto. I need you to initiate all 4 cams. Room is clear.
Starting robot.
Robot is in auto. Initially, when you see this objective start, we're going to load all 4 ICAMs, get them running. When the first round comes out, that's 0 minute to start the stopwatch for our count, because I have the system primed at that point, and the clock will start for the ones after that. During step 27, you heard a ting noise, okay? What that is a mortar is not like a projectile, where a projectile, if we remove the burster well, we have a hollow agent cavity. It happens that in the mortar, we have a baffle assembly in there. We actually have 7 contact points that this has to go in and go past. 1, 2, 3, 4, 5, 6, 7. So if it comes in and catches one, that's the noise that you hear. Objective 5, which is demonstrate reject sequence operations. What we're doing here is we're loading the reject table with the robot. Whenever the robot fills all 6 positions, it should not go back and pick the 7th round up. It now indicates that 6 are present. Control room has an alarm, says reject table is full. We will not pick up the next round.
So my name is Randy Johnson. I'm a plant support specialist at the Pueblo Chemical Agent Destruction Pilot Plant. I work for a minimum. This was definitely a challenging project. We've overcome several obstacles to get to where we are right now. The team has risen to the occasion. We all know that we're getting a good product moving forward.
The aha moment really came for me the day before the FAD, and that was to see the large number of PCAP personnel that are here. They've got hands-on, they're learning the system, and so it's really going to be a very easy transition once we get the equipment in the plant. CRG does an excellent job. Momentum, Bechtel, everybody here that's helping out. It's truly a team effort.
CRG Automation has been pleased to work in collaboration with Pueblo Chemical Agent Destruction Pilot Plant, the Program Executive Office of Assembled Chemical Weapons Alternatives, the United States Department of Defense, Amentum, and others on a successful project.